Okay, we are doing homework 6.2, starting with question 1. So I think this entire homework is related to binomial probability experiment. So let's first of all identify what is binomial probability experiment, because all questions are going to be based on binomial probability experiment. Binomial probability experiment has 4 conditions that need to be satisfied. Okay, these conditions are following. Trials have to be independent. Let me see where we have. Here it is. Number 2, trials have to be independent. Experiment has to have the fixed amount of trials. Fixed number of times. Here is B. Next, the probability of success, it has to be the same from trial to trial. What does that mean? Same has to be the same. That means they don't depend on each other, which means that trials are independent. We already picked it. Okay, and there are 2 mutually exclusive outcome. Outcome can be mutually exclusive. One is success, one is failure. Okay, where is it? Here it is. What does that mean? Success, not literally you can take as a success. Let's say failure also is if it's a subject of our interest in the word problem, that failure can be our success if we find that failure. Well, for example, if we want to find out what's the probability of the computer that school received will fail. Okay, that's whatever failed, we can take as a probability of success because it's subject of our interest. Okay, all right, so let's check it. Bingo. Moving to next question. So what is the formula of expected number of success for binomial experiment and probability? It's going to be E of x equal n times p. So n, let me write down, in binomial probability distribution, n is the total amount of the trials. Total amount of trials. Next, P is the probability of success. Oops. Probability of success. Accordingly, Q, which will be equal 1 minus P, it's going to be probability of failure. I think and PQ, I think that's all. And if I forgot any notation, I will add there. So expected amount, number of successes, E of x is equal n times p, which we also call average. Average amount of successes. It's for binomial probability experiment. It's also mu is equal n times n times p. Okay, moving to question number 3. Okay. Question number 3. Determine if the following probability experiment represent a binomial experiment. If not, explain why. If probability experiment is a binomial, then state the number of trials n. So a random sample of 15 professional athletes is obtained, which means 15 is going to be total n. Is obtained, and the individuals selected are asked to state their age. Since we are talking about age, first of all, let's see, trials are independent because individuals ask separate, and answer of one individual has nothing to do with answer of another individual. And since we are talking about age, and age is a continuous variable, so there is going to be more than two exclusive outcomes, okay, mutually exclusive outcomes. So therefore it's already right there. It's not a binomial not a binomial distribution experiment, okay. So no, because there are more than two mutually exclusive outcome for each trial. Got it. Next one. Moving to question number 4. So determine if following probability experiment represent a binomial experiment. If not, explain why. Probability. So it's the same question. So here we have an experiment. Drug is administered to 200 randomly selected individual, and the number of individuals responding favorably to outcome. Okay. So what do we have here? We have n is equal to 100. And we have trials are independent, right? And with number of individuals recording favorably. Okay, so in this case we are getting that this is, and probability of success is going to be same, and we have two mutual outcomes, favorable, not favorable. So while in previous one it was different ages, so it was more than two mutually exclusive outcomes. So therefore it's going to be yes, because an experiment satisfy all these criteria for binomial experiment with n is equal how many? 200. Nice work. Moving to question number 5. Determine if the following probability experiment represent a binomial experiment. If not, explain why. If probability experiment is binomial, so then state the number of trials n. 4 cards are selected from standard 52 card deck without replacement. The fact that it says without replacement, that's already right away tell us that it's not binomial, because the trials are not independent. So because it's 52, if you don't replace for next card, it's going to be 51 left. So it's affected. The answer is going to be no, because trials of the experiment are not independent. Where is it? Experiment are not independent, and since the probability of success differs from trial to trial. There. Question number 6. So the same question, let's read the question itself. An investor randomly purchased 18 stocks listed on a stock exchange. Historically, the probability that a stock listed on this exchange will increase in value over the course of the year is 45%. The number of stocks that increase in value is recorded. Okay. So what do we have? We have independent trials, right? From year to year, it's growing independently, correct? Next, what else we have? We have the probability of success. It's going to be the independent from 1 year to another year. And we set independent probability of success. We have certain the fixed amount of trials, right? Years, we count. Okay, well, we have answer yes, and n is going to be 18, and probability of success is going to be 46 or 0.46. Okay, 18. And this is going to be 0.46. Okay, what is incorrect? Let me check which numbers I put wrong. Did I put, no, 0.46. Is it 0.40? 45, I'm sorry. I'm trying to figure out what I did wrong. Okay. 45. Okay, finally we got it. Question number 7. Okay, here we are going to have probability or already binomial probability, the binomial probability for given parameters. Here I'm going to use, let me close this. I don't need this. I'm going to use StatCrunch. So let me write down n is equal 15. P is equal 0.2, x is equal 4. All right, let's go. So I'm clicking. Let me see, I think it's stat. Let me look, calculate. Okay, where is binomial? Here is binomial, clicking binomial. And it's getting, we are getting standard. Let me see. Here we have n is 15. Let me put here 15. 1.5. Probability of success is 0. How much? I wrote down 0.2. 0.2. Oh, 0.2. Hold on. All right, 0. Why is it? Okay. 0.2, and our x is 4 or 7. 1 second. 4. Is 4, and we need to choose. When it's equal, then you have to choose less because probability shows to less. Okay, now once we compute, okay, it's screwed up. Let me see if I close, will it show? No. Okay, going again. Let me double check data. 15, 0, 2, and 4. Okay, one more time. Stat, binomial. So we put here 15. Okay. Here we put 2. .2 and x I put 4. Compute, and I got how much? 0. Let me write down. Here it is, 0.83. We need how many decimals? Let me write down all of them and then I'll round it. 8357. Ch.6.2.8. Okay, let's go back to our, oh, do not round the final answer. Okay. Round until the final answer. Okay, then round to 4 decimals. There we go, 4 decimals. So I'm going to get 0.835, rounding will be 5/8. Why is it incorrect? 0. Going one more time. Ah, we have equal sign. Okay, well then put specifically equal sign. That's why. I didn't know it has specifically equal. It usually goes with equal or less. All right, let me write down 0. Rounding till 4 digits, 0.1876. 1876. Moving back. One 876. There we go. We got it. So, and we have how many more? 2 more. Okay, let's go. These 2 more also. Let's answer. Find out. Okay, same thing. We have 8, 0, 3, and 4. All right. 8. Here is gonna be 0, 3, and 4 we have. Computing. And we get 0.1361. Okay, 0.1361. 0.1361. And now we're getting to the last one. So what do we have? Let me see if I can bring that calculator. I need this one. We need to calculate here. So what do we have? Paul found 41%. Okay, that means probability is, let me use this one, 0.41. That several states has poor. Okay, so for 200 randomly selected adults, n is equal to 100. Okay, compute the mean. We need to find mean and standard deviation. Okay, here's the thing. Mean is equal n times p. Standard deviation is equal square root n p cube. So let's figure it out. If n is p is 0.41, then q, probability of failure, is going to be equal 1 minus 0.41, which is going to be 9, and 0.59. So here we have 0.41 times 200, and we are getting, so 0.41 times 200, I'm getting 82. Average is 82, and standard deviation, it's going to be 200 times 0.41 times 0.59. Okay, let's go for it, and then we take square root. 200 times 0.41 times 0.59. We are getting, I get 48.38. And now let me take square root of it. I get 6.95. How much we need to round it? Okay, let me write down the mean first. Doesn't allow me to write down. Oh, here it is. It was 82. Okay, and now standard deviation round till nearest tenth, so it's going to be 7.0, because I got here it is, I'm writing down, I got sigma after square root 6.95557 blah blah blah, so till tenth it's going to be at a 7.0. I'm going to write down 7.0. Let's see. 7.0. Fantastic. We did good job. And moving to the last question. Oh, we are done? No, this one we need to solve. We have further question. Okay. We can solve the further question. What do we have here? So make interpretation. So our interpretation is going to be 200. The mean is the number of them that would expect it, because mu is an expected value, right? Where is it? It's not minimum, but minimum is the number of them that would expect it to believe. It looks like it's going to be C, that the overall state of moral values is poor. Okay, this is going to be because, this one also expected, all right. The mean is the minimum. No, mean is not the minimum. Mean is a number, so it's C, it's not B. Okay, we got it. See. I'm trying to find out where is that. Check the answer. It should be on the site, and it's not going on the site. Let me see. Well, it's not. Here it is, finally. Okay, well, done. Oh, one more. Would it be unusual if 94 of 200 adults surveyed believe that overall state of moral values is poor? No, it won't be unusual, because where is it? Less than 50%, right? So it's not unusual. Since average was how much was our 82? Yeah, average is 82. So no, it's not unusual, because standard deviation is 7, meaning 7 times further than it should be. That's what it means. To understand in details that standard deviation, I would recommend to go watch the video about standard deviation. So because free standard deviation, the thing is, one standard deviation. Okay, let me see if I can write down so to show you. Mu plus minus one standard deviation, that makes 64% of data. Mu plus minus 2 standard deviation, that makes 95% of data, and mu, which is average, plus minus 3 standard deviation, it makes 99.7. Statistics never 100%. So free standard deviation, it's already 100%. But we have their 7th standard deviation, so it's very, very little, right? Okay. Let me see. So it's going to be no, the answer. Let's check. Good job. And I believe we are done, right? We answered all questions. Let me see. Yes. All right. See you in next video.